Today we are going to be talking about properties of exponents. First, in order to understand what a property of exponents is, we need to understand that an exponent is a way to shorten a string of multiplication. So if we had x times x times x, there are three x's being multiplied together there, which gives us x to the third. That is the quicker and more efficient way of writing that string of multiplication of x's. So the first problem I'm going to go through with you is x squared times x to the fourth. Okay, so what does x squared really mean? Well, x squared means there are two x's being multiplied together. And x to the fourth means there are four x's being multiplied together. In total, the order of multiplication does not matter. How many x's are being multiplied together there? If you count them up, there are six x's being multiplied together, making x to the sixth the simplified expression for that problem. Next example I'm going to go through with you guys is what happens when you are dividing like-based exponential expressions. If we were taking x to the fifth over x squared. Okay, x to the fifth means there's five x's being multiplied together. X squared means there are two x's being multiplied together. So we could rewrite the numerator as x squared times x cubed over x squared. In the numerator, there are still five x's being multiplied together. We just grouped them so that there are two x's being multiplied together, then three x's being multiplied together. Well, why is that helpful? We have multiplication in the numerator, which tells us we can divide out these x squareds to 1. X squared divided by x squared is 1, so we really have 1 times x cubed over 1, which just simplifies to x cubed. Is there a shortcut there? Well, ask yourself that. Is there a way to get from x to the fifth over x squared to x to the third? Right. Next example I'm going to go through with you is what happens when we have a power raised to a power. So if I had y to the third squared. What that means is what's in the parentheses is being multiplied together 2 times. So that means we really have y cubed times y cubed. Which brings us back to the example over here, right? Very similar at that point. So we have y cubed times y cubed. We squared y cubed. There are 6 y's being multiplied together there, which gives us a simplified expression of y to the sixth. Last example I'm going to go through with you guys on this slide is 2x all cubed, 2x quantity cubed. What's in the parentheses is being multiplied together 3 times, right? That's what that 3 means. So we are going to take 2x times itself 3 times. Order of multiplication does not matter. I feel like I'm a broken record for saying that. It doesn't. So we're going to reorganize that. We have 2 times 2 times 2 times x times x times x, which gives us 2 to the third, x to the third. 2 to the third is 8, and x cubed is x cubed. Right? So was there a shortcut? Was there a pattern we could have taken to get from the original problem to that step? I'll let you guys see if you can discover that on your own. I'm okay with you writing out that string of multiplication as you're getting going. That's understanding what's going on with our exponential expressions.